Hey there, guys. In this video, we're going to be continuing our work on in Unit 2, looking at our advanced functions. This video, we're going to be looking at explicit and recursive functions. The problems that I'm going to be working with you from are from the practice set. If you get what you need out of what we do together in this practice set video, feel free to skip the tutorial and go straight to the mastery test. If you feel like you need some more help, you can either email Ms. Schaefer and I, or pop in during our virtual office hours to ask us questions, or you can go through the tutorial yourself. Okay, so let's start taking a look. So looking at explicit and recursive functions, it kind of carries on from the lesson where we talked about modeling and interpreting linear and exponential functions. When we're looking at these, here's a chart that I have kind of like summarizing everything that's worked with in that lesson. When we're working with either arithmetic or we're working with geometric. And when we're arithmetic is going to be our linear equations that we're looking at. So these are all those line things that we were doing. So these are our linear equations, and these are all our exponential. So we're in this lesson, we're kind of going to end up running into a couple instances where we're going to have to make the decision between, am I looking at linear data or am I looking at exponential data? The only difference with what we're working with this is now we're interested in either a list or making a list, which is our recursive. Our recursive is used to write out all the numbers in a sequence. And then we can also look at explicit. Explicit is used to find a specific term. So instead of having to make a whole list of things to find like the 37th term, we can use our explicit forms to be able to find the 37th term without having to list all 37 possibilities for that out. And this middle line that you have right here is, those are the equations that we were doing in that first lesson. So this is how they are relating what we did there to the equations that they're giving you here. So if you want to write slope-intercept form, or your y is equal to mx plus b, where our m is the d, the x is the n, because remember that we can write this as f of x, and then the a minus d is our b, or this is going to be f of x is going to be equal to a times 1 plus r to the x power. So those are going to be very similar. Okay. All right. Just a friendly reminder on some of these values. We talked about the common difference in that first lesson, where you're taking the second term and subtracting it from the first, or the third from the second, those kinds of things, and our common ratio for a geometric, which is the b divided by a. For both of these, whether it's linear or whether it's exponential, arithmetic, or geometric, a is going to be the first number or the initial value in your sequence. And then same thing for geometric. N for both of them is going to be the number in the list or the sequence that you're looking for. And then f of n is going to be whatever the function is that we're working with. So pretty much, other than I know the equations are a little bit different, all of the values represent the same thing, except for arithmetic or our linear, we're going to be looking at the common difference. And then our geometric, or our exponential, we're going to be looking for that common ratio. Okay, so let's get in and start working with the problems. In this chart, if you have a way to write it out or copy it down or something to have it out so you could use it while you do these problems, it'll be super helpful, because it's kind of like a flow chart that you can use to help you make a decision for which value is which and which equation you need to use. Right, so if we get started, for the first problem, they give us a sequence graph below shows the number of bicycles detailed per hour in a bicycle shop. So with this one, the decision between whether we're working with linear, exponential, or the arithmetic versus geometric, it's not a hard decision to make, because if you look at this makes a line. These numbers go up by the same value. They're going up by 2s, or the ones we can see they're going up by 4s, and this one is going up by 2s, or sorry, 1s, or the numbers that they got going by 2s. So this is a consistent increase for both of these. So we can look at these dots and say, okay, that forms a line. They want us to determine the recursive formula. So this is where you would go and say, okay, they want the recursive formula, and this is arithmetic, or it's a line. So this is the form that I need to be using. And they start filling it out for us. So the recursive function that describes the situation of f of 1 is a, and they tell us that a is 4. So I've got, or I'll just rewrite it down here. So I've got f of 1 is 4. And then they want us to fill in this first box. So they give us a drop-down box, and all this basically is a do you recognize what this function is supposed to look like? And if you've got this pulled out or written down, then that's exactly what goes in that first box. You're just recognizing, hey, this is what a recursive function looks like. So I've got f of n is equal to f of n minus 1 for n values greater than 2. I didn't write that part of the definition there. And then they want to know, they want to know what goes in this box, plus what? Plus that common difference is what they're looking for. So if I'm looking, this goes up 2 over 1. So my common difference for that one is going to be 4, 6, 8. So it really goes up 4. It goes up 4 over 1. So my common difference, this guy's going to be equal to 4. So my f of n is going to be equal to 4 times n minus 1 plus 4. And again, I got the plus 4 right here looking at my common difference. So these go up by 2s. So 2, 4 over 1. 4 over 1 gives me my common difference of 4, which is our slope. That's what that number is. That's our slope. And then they want to know what f of 9 is. So they want you to take this equation that we've got here that we've been working with and find out what that 9th value is going to be. But if I go and I can't plug it in here, because what this says is in order to be able to use this value, you have to know what the term before it was. So we've got to start at f of 1. So if f of 1 is equal to 4, in order to find f of 2, I'm going to take the term before it. So the 4 from here is the one that's going to go here. So 4 plus, and then I'm taking this term right here, 4, and that is equal to 8. So then if we find the third term, I'm going to take this term right here, that term that came before, and add 4 to it. So 8 plus 4 gives us 12. And then I could do f of 4 is equal to the term before, 12 plus 4 is equal to 16. And if you look, these values that we're calculating and writing down, they're showing up on our table. So when our x value or our n value was 1, the value that we had was 4. When our value was 2, the value we ended up with was 8. When our value was 3, our n value was 3, our f of n ended up being 12. So looking at 4, we've got 16. So without really having to calculate it, we could go f of 5 is going to be equal to 16 plus 4, or by looking at our graph, it tells us that it's 20. So that gets us to 5, but they want 9. So using our recursive formula that they have us using, we are going to need to continue this to get to 9. So we can do f of 6 is equal to 20 plus 4, 24. F of 7 is equal to 24 plus 4, 28. F of 8 is equal to 28 plus 4, which is 32. And then f of 9, which is what we're looking for, is going to give us 32 plus 4, which is going to be 36. So the answer that goes in that drop down is going to be 36. And that's what they're looking for that one. There is another way that we could have found this term, we could have found it using our explicit formula. Looking back here, looking at our explicit formula, we could have plugged it in there and got our value that way. Because we know what our A is. We know our A is equal to 4. The first term that we start with is 4. And then that common difference that we found by finding the slope, we could take that and plug it in there and do it that way. So if I write it down to show you what that looks like, I'll write it down and then I'll talk to you. Okay, so if we look, this is our term that helps us find, this is our explicit equation that helps us find a specific term. So if we're looking for that ninth term, I could say I want to find the ninth term where I plug in 9 for n, and that's going to be equal to the first term that they told us, which was 4 plus that common difference that we're looking for, 4 times n, but we know our n is 9 minus 1. So f of 9 is equal to 4 plus 4 times 8. So f of 9 is going to be equal to 4 plus 32. So our f of 9 is going to be equal to 36. So there's that answer that we were looking for this way. So instead of having to write that whole list out using that recursive form, you could just have switched over to find, for this answer right here, for finding the f of 9, we could have switched right over to the explicit. And then done it that way. It doesn't matter which way you do it, just whichever way makes sense. As long as they're not specifically asking you to use one version or another, you're fine. So we had to use the recursive for what we were doing here to be able to write this equation to fill in these values here, but it didn't tell us that we couldn't use the explicit for there. So it's whichever one you want to use. Okay? All right. So looking at the next problem. So they've got a new clothing store, uses advertising through social media to draw customers and increase the number of transactions each month. The number of transactions, or f of n, for n months is shown in the table below. If the number of transactions per month continues to increase this way, fill in the values for a and r to create a function that describes the situation. So if we're looking at this one, the only thing we need to find a value is for a and for r. So if you remember those definitions that I gave you over here on this page, a is the first number or the initial value. So if we're looking at our table where they say month 1, this value of 10 is our first value, or our first term, or our initial value in what we're working with. So our answer for A is going to be 10. So then we need to find R. And remember, we find R by doing B divided by A. So we need to take these terms and then divide them out to make sure we end up with the same number. So if I do that, and I look at these two terms, I'm going to be doing 20 divided by 10 to give me 2. And then here, I would do 40 divided by 20. That's going to give me 2. And I'm just checking to make sure. That way they didn't sneak one in on us. Or if we read the problem incorrectly, this is a good place to catch it there too. A divided by 40 is 2. So that is our common ratio. When we divided, we got all of the same numbers. So that's going to be our common ratio of 2. And that's our answer for that one, because all it asked for was for A or for R. It didn't ask for us to fill in on anything for N or F of N. So that's going to be our answer for 2. Taking a look at 3, they have Daniel collecting stamps. His grandmother gave him 24 stamps to start with. Every week, Daniel's collection increases by 8 stamps. Let Y represent the total number of stamps Daniel has after 8 weeks. So again, I'm going to break these sentences down into parts, figure out those individual parts before I move on to the rest of the sentence. So the first one, the first couple words are exactly the same. And then the first big difference that we have between those sentences is we need to make a decision between whether it's a geometric sequence and an arithmetic sequence. And this is the same decision we were making in our other lesson, except instead of calling them arithmetic and geometric, For these, they are calling them linear. We called them linear and exponential. So keep that in mind. You're making the same decision you were made before. They're just using different vocabulary for it. Okay. So if we look, the collection increases by 8 stamps. It's the same amount every single time that it's going to increase by, and it's always going to be predictable. So that makes this be what we talked about in that last lesson, a linear. So if we look back, linear matches up with arithmetic. So I can go through and automatically cross out all of the ones that are going to be geometric. And then from there, because the successive y values have a common difference of, it's either going to be 8 or it's going to be 24. So I need to figure out what that common difference is going to be. So if I look back at this chart, we find the common difference by doing previous term minus first term. So let's see, we start with, he started with 24. We don't have anything to subtract, so we don't want to subtract those two. So then I'm looking at what's left. We started with 24, and then it increases by 8. So the amount that it's changing by for each problem is going to be 8. So that's going to be the common difference of 8. It can't be the 24 because that's what we start with. So we're looking at our common difference is going to be 8. So it's going to be the second answer right there. Looking at problem 4, the weight of vegetables transported by a farmer to a nearby market increases by 15% every month. So hopefully you're kind of already going 15%. That means that is going to be exponential, and using our new vocabulary, exponential means it's going to be a geometric sequence. So a farmer transports 460 pounds. So I'm going to write that down while we've got it in our minds. It's going to be geometric. So I also wrote down that was exponential from what we did in the last lesson too. So a farmer transports 460 pounds of vegetables in April, 529 pounds of vegetables in May, 608.35 pounds of vegetables in June, and 699.60 pounds of vegetables in July. Approximately how many pounds of vegetables will be transported in the market or to the market in August? So we can make a list out of these, and I'll make my list, and then I'll be right back. All right, so I've got my chart up on the board. I took all the information that they had there, and I put it up here. And then if I'm looking, and since I know that this is exponential, if I want to find my common ratio, I can do 529 divided by 460, and that will give me the 1.15 of an increase. And if you notice, right here it says it increases by 15% every month. So if we take the 1 plus r that we were working with last lesson, we can go our 1 plus 0.15, and that's how we get that one right there. So you can either go through and divide it out like that to find the 1.15, or you can remember what we used last lesson mixed with this in order to figure that out. So the way that you go from here to here is you're going to take that 699.60 and multiply it by that 1.15, and that will give you the 804.54 pounds that was transported in August. With these, you could probably sit through and figure out the equation and use the equations. For me, since this list is so little and they give you the one right before it, I feel like it's easier just to multiply that way. Looking at question 5, the outstanding balance of a credit card bill is $250. According to the credit card company's policy, an interest fee of 2% on the card balance it will be applied each month the bill is not paid. Assuming that the bill is not paid, what is the outstanding balance after 6 months? So if we're looking at an interest fee of 2%. So if we're making our decision between whether this is a linear or exponential or an arithmetic versus geometric, it's going to be exponential, which means it's going to be a geometric thing that we're working with. So I'm going to get the information up on the board. With this one, next decision you have to make. So we know it's going to be geometric. So then we need to decide whether we're going to be using this equation here, or which is our explicit form, or we're going to be using our recursive equations down here. So looking what the problem's asking us for, it's asking us for the outstanding balance after 6 months. So I mean, we could make that list of what the 6 months are going to be, or we could just kind of pinpoint what that 6 month is. So we want a very specific term. We want the 6th term in that sequence, so I'm going to be using that equation right there. Okay, so I just need to go back and look and figure out exactly which values go where. So in order to be able to solve this, I need a value for n, so I need something to plug in for n. I need a value for a, so I need to figure out what a, remember a is the first term or the initial value that you start with, and r is going to be our common ratio or our common difference. So if I'm looking at this, we've got the outstanding balance of the credit card bill is $250. So that's what we started with. So that's going to be our a value. So we've got $250 for our a. And then according to the credit card company policy, the interest fee is 2%. And remember, to find that, we're going to do our 1 plus our rate for what goes there. And then our rate, they tell us, is 2%. If I switch it to a decimal, move it over 2 spots, it's 0.02. And if I add it, it's going to be 1.02. And so then we just need our n value. If we're looking for our n value, it is going to be balance after 6 months, the amount of time that passed. So I've got 6 to go there. So if I plug in all those values, our f of 6 is going to be equal to 250 times 1.02 to the 6 minus 1. And then I can simplify that a little bit. So f of 6 is going to be equal to 250 times 1.02 to the 5th power. And whenever you put that in your calculator and calculate it, you should get $276.07 is going to be the amount that is owed after 6 months. So that's going to be 276.02, my bad. So it's going to be that one right there. Looking at 6, a certain type of bacteria is enclosed in a glass container on March 1st. The sample of bacteria starts to grow and cover the bottom surface of the container in such a way that the area covered by the bacteria doubles every day. If it grows, so doubles. So automatically, I'm thinking this is not linear. This is going to be exponential, which means we're going to be using our geometric forms. So if it continues to grow in this way, the bottom surface of the glass container will be entirely covered with bacteria on March 10th. When will a quarter of the bottom of the surface of the glass container be covered? So I'm going to work on getting this up on the board, and I'll be right back. So looking with this one, I decided to make a chart out of this one. So I've got March 1st, 2nd, 3rd, 4th, 5th, all the way up through the 10th for what it would be. And then it's got me working with, I need to figure out the number of bacteria that we're working with. So what I did is I just said, okay, well, I guess we're going to start out with 1 bacteria, and that's what they're going to put in that petri dish to, or that glass container to see how much it's going to grow. So, and it says it doubles every day. Right here it says the bacteria, the amount that it covers is it's going to double. So if I double that, 1 times 2 is 2, 2 times 2 is 4, 8, 16, 32, 64, 128, 256, and 512. So there's going to be, it's going to cover 500 and there's going to be 512 bacteria that 10th day. So it wants to know, it's saying that this is 100% covered on this 10th day. So 512 bacteria is the amount that it would take to cover that. They want to know when will a quarter of the bottom of the surface be covered. So if we take this 512, which would be all of them, and divide it by 4, that'll give us 24%. So 512 divided by 4, because we're looking at 25%, which is a quarter of what we're working with. Quarters are divided into fourths. So 512 divided by 4 gives us 128. There are 128 bacteria on March 8th. So that makes the answer be this one. Looking at the next problem, the geometric sequence graph below. So this is nice. They tell us exactly what we're working with. The geometric sequence graph below shows the number of mold spores in a petri dish per day. Determine the recursive formula that describes the situation. So on my board, I'm going to write down the definition for what the recursive formula is. So there's the definition, and now all we need to do is to find values to go in for that one. So we need to know what A value is, that initial value. We also need to know what goes in for the value in front and for D right there. So what D is going to be equal to, that common difference. Hold on, let me double check that. Okay, so for this one, I wrote down this part of the equation wrong. You can't have a common difference whenever you're looking at geometric sequences. So I've got f of n is equal to r times f times n minus 1. So we don't need a common difference. We need a r, our common ratio. Okay, there we go. All right, so we need to find out what f of 1 is, what that first value is. So if we go to f of 1, or where that first value is, these are going up by 2's. So our f of 1 is going to be equal to 2. So f of 1 is going to be equal to 2, because looking at that graph that they give us, they tell us that that value is going to be 2. So then we need to figure out what our common ratio is going to be. So a couple different ways that you could do that. The way I'm going to do is I'm going to look at these numbers and find that common ratio. So here I've got 4 over 2, which is going to give me 2. If I check out the next ones, I've got 8 and then 4. So do 8 divided by 4, that is also going to give me 2. So it's looking like our common ratio is going to be 2. So 16 divided by 8, also 2. So our common ratio is going to be 2. So our f of n is going to be equal to 2 times f of n minus 1. So if we look to find the one that matches, it's going to be, our f of 2 is 2. It's going to be this last one right here. All right, so taking a look at number 8. The recursive formula for the geometric sequence is given below. What is the 7th term of the sequence going to be? I'm going to get that up on my board, and then I'll be right back. Okay, so I took the information that they had there, and I put it up there. I also just went ahead and wrote down the definition for recursive, so I had all the values there. So I could start figuring out and plugging in values and writing the list all the way to the 7th term in the sequence, or I could just use the explicit. It doesn't say you have to stick with recursive the whole way, so I'm just going to go ahead and stick it to explicit. When I use the explicit, I just need to know what my A value is equal to and my R value is equal to, and I can get that from this information over here. My A value is going to be equal to 5. My R value is going to be equal to 3. So then all I need to know for this equation is what my N value is, and I get it from the problem where it asks for the 7th term in the sequence. So our N is going to be equal to 7. So then I'm looking at f of 7 is going to be equal to 5 times 3 to the 7 minus 1. So f of 7 is going to be, and remember you've got to do your order of operations first. You've got to do your exponents. So we're doing 5 times 3 to the 6th. So if you do 3 to the 6th in your calculator, you're going to get 729. So I've got f of 7 is equal to 5 times 729. And then I'm going to multiply that by 5. So f of 7, so the 7th term in that sequence is going to be 3,645. So that's going to be that last answer there. Looking at question 9. Tracy is practicing singing for a competition. She increases the length of her daily practices by the same amount each day and records her time in the table below. Select the explicit function which defines the sequence represented by the table. So looking at this, they've already made it very clear that this is a linear function or an arithmetic function. So then we own, like this is in slope-intercept form. This is y is equal to mx plus b. So all we really need to do is find our slope and then go from there. So if we do our slope, we can do 36 minus 25 over 2 minus 1. So calculator, 36 minus 25 is going to give us 11 over 2 minus 1 is 1. So we've got positive 11 is our slope. So I can automatically eliminate this answer here and this answer there. So then the big decision we need to make is it going to be plus 14 or is it going to be plus 25? Remember that this is our b value. This is for where our x values are equal to 0. So if we look, day 1 is 25. So our the y-intercept or the graph crosses the line cannot be 25. So we would need to think about what is day 0. What value do you have before that first day is over? So you can do, these are going up by adding 11. So you can do 25 minus 11 to give us 14. So our day 0 is going to be, which could, is going to be 14. So that makes our answer for this one going to be the first one. Looking at problem 10, select the correct type of sequence and recursive function for the sequence below. So again, I'm going to break this into its bits and parts and go from there. I'm going to write these numbers on the board so it's easier to play with. Okay, so looking at our sequence up here on the board, big decision we have to make is it going to be a linear function or an exponential function, or in the terms for this lesson, arithmetic or geometric. So the first one that we have to figure out is, do we have a common difference or do we have a common ratio? So remember, common difference, you're going to take a second or third term and subtract it from the one right before it. And then for the common ratio, we're going to take that second, third term and divide it by the one before that. So I'm going to do 40 minus 34, and that's going to give us 6. And then 46 minus 40, that is also 52, not divided. 52 minus 46, that is also going to give us 6. So because these numbers ended up all being exactly the same, we know that this is going to be a linear, which is what we worked with, the vocabulary we worked with last lesson. But for this one, it's going to be arithmetic. So I can go and I can automatically eliminate those two. So then the next thing that it has us working with is our first term is 34. It's the same for both of them, so that's not enough to help us eliminate what's going on. And it looks like that form that they're using there is the recursive form. So it's looking at f of 1 is equal to a, and then f of n is equal to f of n minus 1 plus d. That's the form that it's working with right there. So if we plug that in, the f of a was 34, like we said earlier. So then all we need to do is find what our common difference is going to be. Well, going from here, we found it's going to be a plus 6 because they're adding 6 to each of them. So it's not going to be a minus 6. It's going to be a plus 6, which would make the answer be that one right there. Looking at 11, Andrew bought a new computer for $2,100. The value of the computer decreases. So automatically, I hope you're thinking that this is an exponential or a geometric function. Let y represent the value of the computer after x years. Which type of sequence does the situation represent? So we already said, since it's got that 30%, it's going to be exponential or geometric. Those two words mean the same thing. So there we have those two. And because the successive y values have a common ratio of, and now we need to make the decision between the 0.7 or the 0.3. So with this is what we were looking at last lesson, whenever we were doing the 1 plus r to figure out what that value would be. So with this one, it decreases by 30%. So we're doing the 1 plus, and it's a decrease, so negative 0.30 if I switch it to a decimal. So 1 plus a negative 0.3, if we put that in our calculator, is going to give us 0.7. So the rate for this problem is going to be 0.7. Looking at question 12, Charlie and his friends are playing a game. They started round 1 of the game with 27 people. The number of peoples in the first 5 rounds is shown in the table below. Which of the following is the explicit function that can be used to determine the people remaining in the nth round? So if we're looking, it says number of people. It's written as a line or as an arithmetic, so we don't need to go through and make that decision. We just need to find out what the slope is and what our y-intercept or our 0 term is going to be. This was first, second, third, fourth, fifth for the rounds. We need to figure out what the 0 would be. So if we go and we look, these are going up by 1. So then looking for that common difference, because they tell us that this is linear arithmetic, so that's how I know we're looking for common difference. 25 minus 27 is a negative 2. So they lost 2 people between rounds. And then 23 minus 25, also a negative 2. 21 minus 23, also negative 2. And then 19 minus 21, also negative 2. So we've got a common difference of 2. So each round, 2 people are going home. So that means we're either looking at this equation or that equation. So then we're looking for our y-intercept, and remember that's where our 0 is going to be. So if we're subtracting by 2's to work our way this one down the table, we need to add 2 to work our other way. So we're looking at 29. Another way to look at it is this is where our x is or our n is equal to 0. So if this is 1 and this is 27, this one can't be 27. It's got to be the 29. Looking at 13, the number of goats on a farm changes from year to year because of the following 3 factors. And each of those 3 factors is going to show up in this equation one way or another. The number of goat births each year is equal to that year's population. So that's kind of another way of saying that things have doubled, that things are multiplying by 2. 30% of the goats are sold each year. The farm adds 5 goats apart from those born in the farm. So if I just use we'll go look at the equation first. So the farm has its initial population of 20 goats, and n denotes the number of years with a recursive equation, gives the population of goats as a function for year f of n. Okay, so this right here, these are all the same. I'm breaking it down bit by bit, just into individual pieces to figure out the parts. So looking at this, we've got f of 1 is equal to 20. So if we're looking at that, that's our initial. So the initial population, 20 goats. So that doesn't really help us narrow down anything. So I'm going to go and work through the the values that they have up here, and that's kind of how they've got them lined up down here. So for the very first one, it says that the number of goats for this guy, the number of goat births each year is equal to that year's population. So it's going to effectively double, because if the population is, I don't know, well, they tell us, we do know. So if the population is 20 goats and the number of goat births is equal, so they would have 20 born. So it's pretty much your population is doubling. So that would be a common ratio of 2. So that allows us to eliminate those 2. So 2 times the year that you had before. And then it says here that 30% of the goats are sold every year. So if we're looking at selling goats, we're not adding more goats to the current collection that we have. So that's going to be subtracting 0.3. And then looking at that last, it says the farm adds 5 goats. So we're looking at a +5. So that just kind of confirms what we were thinking here. So the answer for this one is going to be the second one. Looking at 14, it says select all of the correct answers. So Sophia has a book fund to save money for her college textbooks, and she also works a part-time job. Her grandmother has given her $1,000 to help start the fund. Since she is working, she adds $50 to the fund each month from the money she earns. Select all the functions that can be used to find the total amount of money in College Book Fund after N months. So what I did with this one was, instead of looking at all the different options that they had to start with, I started with writing out the functions on my own, looking at different things. So I first had to make the decision of, is this arithmetic or geometric? Is this a linear or is this an exponential? Well, every month she's adding exactly $50. It doesn't change based on the amount that she had before. So that makes this be a linear. So what I'm going to do is I'm going to write down the forms of linear options that I have and be right back. Okay, so what I've done is I've gone through and I've written down all of the 3 from that chart that I gave you, and this is where I got those. I went and I've got linear, I've got arithmetic, and I wrote them all down. So here's my explicit, here's my slope-intercept form using the values that they gave us here, and then here's my recursive. So I'm going to take that information from the problem that we're working with and just fill in all of those values there. So I need a value for A. Remember, A stands for that initial value. She was originally given $1,000 to start with. And then I need a value for D, or our common difference. So that is going to be that she adds $50. So D is going to be a +50. If she had been spending money for whatever reason, I would have done a -50 instead. But she's adding money in. So it's going to be a +50 there. So then I'm just going to take all of these values and put them in and go from there. So I've got f of n is equal to A. A is 1,000 plus D, which is our 50, times n minus 1. So that's going to be one of our equations that I'm going to look for here in a second. And then we could also have f of n is equal to 50 times n, the n stay in there, plus A minus D, or 1,000 minus 50. So I'm going to simplify just in case that's one of our options, is equal to 50n plus 9,050. So these are possible answers that I could be looking for. And then if I plug it in here, I've got f of 1 is equal to 1,000. And then f of n is equal to f of n minus 1 plus 50. So these are my 3 options that I could have that I'm going to be looking for one way or another in the information that they give us. So for the very first one, they've got 950n plus 50. And if I look, I've got the equation right there, but they've switched these two. So we're looking for selecting all of the correct that can be used. So this is wrong, so I'm not going to check that one. So then f of 1 is equal to 950. That goes to in the same form of this one. And f of 1 is not 950, it's 1,000, so it can't be that one. And then f of n is equal to 50. Oh, that matches. Plus, it's not plus 1,000, it's plus 950 because we had to do that subtraction. And then 50n plus 950, so it's going to be that one. And then 1,000, f of 1 is equal to 1,000. And then f of n minus 1 plus 50. So it matches that one right there. So with this one, I feel like these types of problems will go a lot better if you take the information that they give you in the problem, write down those equations that you know from that chart that I gave you to work with, and then plug in and simplify things from there, and then that way you're less likely to get confused and pick things that are incorrect. Okay, looking at that last problem. So drag the tiles to the correct boxes to complete the pairs. Not all the tiles are going to be used. Match each explicit formula to its corresponding recursive formula. So we're setting up those equal values. So give me a second. I'll be right back. All right, so I've taken what they've got written in these boxes here, and I wrote them up on the board here. And then I've also taken and I've written down the definitions for what we're working with. So it says we're working with recursive, which is what we started here. We've got to make a decision whether it's an arithmetic or a geometric recursive formula, and then they want us to match the explicit one to it. The reason why I'm focusing on these three is because up here they give us 6 options. So we can either switch these 6 options and see where they match down here, or we could switch these 3 and then match them up here to the 3 that end up matching up here. Okay, so I'm going to go through, and to me the arithmetic ones are easiest to do first, so I'm going to go through and find those. The easiest way I have found to tell the difference between the arithmetic recursive function and the geometric is arithmetic has the plus d at the end, but if you notice, all of these has a plus d, so that's not 100%. But the one that they always will have is for geometric is times r. So if I look, there's no r times for these two. This is an r times. So that tells me that this one's an arithmetic, this one's an arithmetic, and this one is a geometric. So I'm going to start with matching these two up to the ones they belong with. So if I'm looking to switch, I need to have an a value and I need to have my d value. So if I'm looking, my a value is the one on the other side of the f of 1, so my a is going to be 5, and my d is going to be this value right here. It's going to be a positive 5. So if I plug it in, f of n is going to be equal to 5 plus 5 times n minus 1. So if we go up here, 5 plus 5 times n minus 1, there's that guy right there. And then doing this last one right here, my a value for this one is going to be 5, and my d value, this one right here, d is going to be equal to 13. So if I plug it into this one, f of n is equal to, my a value is 5 plus 13 times n minus 1. So 5 plus 13 times n minus 1. So then that just leaves the geometric one. So this isn't a nice and neat geometric. And the part that makes it be not nice geometric is the fact that they had put the minus 5. If they had left that minus 5 off, we could do the same process that we did for these two. We figure out what our a value is, which is 5, and our l value is going to be 3. But then we've got to take into consideration that minus 5. The easiest way that I have found to do this is to make a list. So I'm going to pause, erase the extra stuff, and then just focus on that geometric here in a second. Okay, so taking a list out of making a list out of this, I'm going to so I've got my n values, and then I've got what my f of n is after I plug those in. So when n is 1, my f of n is going to be 5. So then I need to figure out what my second value is going to be. So if I plug it into the equation that we've got, f of 2 is going to be equal to 3 times, remember this right here means the number before it. So 3 times 5 minus 5. So f of 2 is equal to 3 times 5 is 15 minus 5 is 10. So my when n is 2, f of n is going to be 10. So then I'm looking at f of 3 to set up a third. That is going to be equal to 3 times f of n minus 1, that number, what the answer was for the problem you got before it. So 3 times 10 minus 5. So f of 3 is equal to 30 minus 5 is 25. So 3, 25. And then we're looking for the number before it. So then we're looking at, or the next number. So we can have the next number. So f of 4 is going to be equal to 3 times 25 minus 5. So f of 4 is going to be equal to 70. So then from there, I'm going to start plugging things in to match them up. So if I'm looking, going from here to here, 10 divided by 5 gives me 2. But remember, when we're looking at these, this works for all numbers greater than 2. So the number we got between those two isn't going to work out for us and give us the answer we need. So 25 divided by 10 is going to be 5 over 2. And then 70 over 25. Let me plug in my calculator, make sure I have this value right. 70 divided by 25. And then switch it to a decimal. Will give us that same. So then we're looking at, well, we've got our 5 halves here. So we've got our, here's our 5 halves. Our R value, here's our 5 halves. Our R value is 3 to the n minus 1, and they've got that plus 5 halves because they had the subtraction there. They do not give you one this hard looking in your mastery test, so you really don't need to really super stress. I would make sure to know the simple ones, so that if they had one where it wasn't the minus 5, you could be able to plug those in, and then you'll be okay. All right, so if you've got any leftover questions, feel free to email either Ms. Schaefer or myself, or come in and join in during our office hours, and we'll take a look at what you're working on and help get you unstuck. All right, guys. In the meantime, I will see you in the next video, and take care.